Let's get started in Chapter 2. In the first section of the chapter, there are three main objectives. We want to talk about the distance formula and also the midpoint formula, and then we want to review graphing a function. So let's start now with the distance formula. We can use that formula to find the distance between 2 points in the coordinate plane. And so for an example, we might want to find the distance between the point at -3,5 and the point at 6,1. And so the graph is not necessary, but maybe it's nice to get a visual interpretation of the problem. So I have a coordinate plane here with an x-axis and a y-axis, and I've plotted the points at -3,5 and also at 6,1. And then the question is, what's the length of the line segment that connects those 2 points? And so there's a formula that we can use to find that distance, and I'd like to show you where that formula comes from. And so let's talk about a general case. Suppose we have a point P with coordinates x1, y1, and a point Q with coordinates x2, y2. Then if we want to find the distance between those 2 points, then the key is to think of the line segment from P to Q as the hypotenuse of a right triangle. And so what that means is I want to draw a vertical leg and a horizontal leg to make that right triangle. Now, from this right triangle, we can get the length of the 2 legs, the horizontal and the vertical legs, and then we can use the Pythagorean theorem to calculate the distance d in terms of the coordinates x1, y1, x2, y2. So how do we do that? Well, let's look at the horizontal leg first. The x coordinate here at the left end is x sub 1, and the x coordinate at the right end is x sub 2. And so what we want is the length of this line segment. And so that might be a little tricky to visualize. So let's draw it. Let's label it out. Let's draw it one more time here. So the distance from the y-axis over to this first point is x1. The distance from the y-axis from the origin over to the second point is x2. Well, what we want is this distance right here from x1 to x2. So what we can say is that we take the entire distance x2 and then we subtract off x1. And what we're left with is exactly what we want, x2 minus x1. So that is the key idea. The length of the horizontal leg is x2 minus x1. We could use a similar approach for the vertical leg, and we can say that the length of the vertical leg is y2 minus y1. And then, when we apply the Pythagorean theorem, remember it tells us that a squared plus b squared is equal to c squared. I hope you won't mind if I write the c squared over here on the left instead of on the right. So c is the hypotenuse of the right triangle, and a and b are the legs of the right triangle. And so in our example here, the length of the hypotenuse is called d. So we'll write d squared is equal to, and then for a, we have this horizontal leg, x2 minus x1, quantity squared, And for B, for the vertical leg, we'll write y2 minus y1 quantity squared. And then we can just apply the square root property, which we learned in chapter 1. It says that we can drop the square off of the left-hand side if we just put a square root on the right-hand side. x2 minus x1 quantity squared plus y2 minus y1 quantity squared, all under square root. If you remember, the square root property actually says there should be a plus or a minus out here in front of the square root. But we don't need the minus sign now because distance for us is always positive. So we can discard the negative, and here is the formula that we want. This is our distance formula. So let's go ahead and go back to the example that I showed you, and let's practice using the formula. You'll need to memorize that formula before the next exam. So it might be a good idea if we just write it out again. D is equal to square root x2 minus x1 squared plus y2 minus y1 squared. And of course we have to be real careful that we substitute correctly for each of these variables. And so let's just go back to our 2 points and label them x1, y1 and x2, y2. And then when we make our substitutions, we should get 6 minus negative 3 inside the first set of parentheses, and 1 minus 5 inside the next set of parentheses. And then we can just simplify. We'll have 9 squared plus negative 4 squared under the radical. And then that's 81 plus 16, which is 97. So our answer is the square root of 97. We need to make sure that we're not able, we need to simplify that square root if we can. In this case, we're not able to, so we'll leave it as the square root of 97. And then you might like to write it as a decimal. That length is approximately 9.85. Most of the time, the homework will ask you to leave your answer as a radical, as an exact value. The other thing I wanted to point out is that it doesn't matter which point you call x1, y1 and which point you call x2, y2. So we could switch the 2 points. Of course, the distance between those 2 points would still be the same, and so the answer must still be the same. And you can convince yourself of that by simply substituting into this formula again. Just switching the 2 points. Call this one the first point and call this the second point and get the same answer. Okay, we'll go on to the midpoint formula next.